And hello everyone, welcome. That's Alex Volochnev, developer advocate of data stacks, and maybe you've seen me already at our workshops, we do a lot. But today, our special guest is Rahul Singh. Hi Rahul.
Hey, how are you doing, Alex? Good to
Yeah,
see you again.
I'm happy because it's Tuesday, we do a stream, and most of all, I'm happy to work with you again. It's been a
Yeah,
while since last time.
Cassandra to India. Yeah,
Yeah,
it's been a
right, right. Okay, so could you please introduce yourself? There are maybe many people or some people who don't know you yet.
Sure. Thank you. Well, thanks for having me. Hey, everybody. My name is Rahul Singh. I'm a platform architect with Anant, and I've been working with Cassandra and DataStax for a long time, and just love building, designing platforms that run on top of data stacks and other technologies. Basically, global platforms. And if you're making a global platform these days, you basically have to use Cassandra. So that's why I'm here.
Right, there are not so many options, but great. And what is it? That's going to be a series, so it's not a single workshop, but like a little TV series. And what it's all about?
Yeah, so this is first of a three-part series. We're going to talk about the general planning of migrating to a serverless platform, just not just the data aspect of it, but the holistic platform. If you're trying to take what you have, even if it's on the cloud, quote unquote, how do we think about it as a serverless platform where you don't necessarily have to manage infrastructure? The second talk is going to be about migrating the data, the ins and outs of how do we plan that and do it. And there will be a few tools we're going to go and talk about, especially if you're moving tons of data, right? If you're using Cassandra, or if you're moving to Cassandra on a system like Astra, how do we get that information there? And then finally, what does true transformation look like? And we're going to touch a little bit of that today in terms of the future of computing and digital platforms, where basically nobody's managing any servers at all. All we do is write functions and design data,
Yep.
and the robots take care of the rest of it.
Yeah, that is great. Well, that's a very interesting topic. We know how many companies now are moving to the cloud. More and more companies doing that. And some of them claiming like quite exciting results, much bigger flexibility, a lot of savings sometimes. But you have to be careful with your cloud infrastructure, or savings may be not really savings. We've seen that also. So we are here to help you to plan to success with the cloud, because if you not plan at all, it's going to be a plan to fail.
That's true.
So let's
That's true.
start.
Awesome. Well, good morning, good afternoon, and good evening from wherever you are. It's actually evening for me here. I'm in Greece today, working from Greece, and so hi to all the folks in Europe and in India and the U.S. Uh, as I mentioned, we're going to talk about the planning and the migration of an application where it has a lot of different components, and we're not going to have actually any hands-on for this session. So don't worry about it. You don't need to pull up your browser and open up any shells right now. I just talked a little bit about myself, but I'm also a CEO of Anand Corporation. Although I do a lot of technical work, one of my passions is to organize knowledge, and we started this little experiment a long time ago called Awesome Cassandra, which somebody was maintaining, and that became Cassandra.link. And we actually run Cassandra.link on some of the stuff we're going to talk about. I also co-organize several meetups in the Washington, D.C. region on Cassandra and on data engineering. We actually have a weekly Monday data engineers lunch at 12 Eastern, uh, roughly 6 p.m. Or 5 p.m. Central European time. And then on Wednesdays, we do Cassandra lunch. So tomorrow at 12 Eastern, you can check us out.
Sounds interesting. I have to join.
Yeah, no, that'd be great. Um, do you want to talk a little bit about?
Yes, sure.
Mhm.
So a little bit of housekeeping before we start. The primary thing of this is the live stream, so you can attend it and ask questions. We stream on YouTube as a primary platform at DataStax developers channels. By the way, it's an awesome channel, so if you didn't sign it yet, do it. There is a button right under the role. Then we have a backup platform, which is Twitch, but we don't watch the comments in Twitch, so we prefer to stay on YouTube as long as everything is fine with YouTube, and you can switch to Twitch if anything goes wrong. Then, for questions, best place to ask questions, you can ask questions right on YouTube comments, but best place is to do it is our Discord community, Fellowship of the Cassandra Rings. And that's you can find it using the link which is right on the screen right now. Next, for today we won't do Menti and practical parts, but it's all coming on the next steps, so stay tuned. And yes, I think we are good.
Excellent. Thank you. Yeah, we're going to come up with some exciting questions for next time. So if you're here next week, there may be some good questions from today's session.
And good prizes.
Absolutely. All right. So just a quick rundown of the series. Today we're going to focus on the platform, right? How do you plan a migration? Next week we're going to talk about data migration. And then finally the week after that, we're going to talk about just true transformation in general, how to achieve it with today's technologies and how to look forward to the future. What do I hope for you today? Well, I hope that you understand the, what is a serverless architecture, right? People talk about it. And to get there, what we'll do is if you don't know about how we got to serverless architecture, I'll show you how technology has changed. And the reason I'm going to do that is because that should show you how potentially technology will change in the future. Why do we want to transform to serverless architecture? What are some patterns to steal from other people? There's lots of best practices out there. So yeah, what are some best practices that we can use? And just a little bit of managing a migration. What are the steps to take? And the actual takeaways are really to just compare what is out there in the world that complement Astra. If you're going to be using Astra. Astra provides an amazing data layer and an API layer, but you have to have other tools and technologies to really make great use of it to maximize that potential. And in different clouds, those are different components. We'll talk a little bit about different clouds like Google and Azure and Amazon and how Astra fits into that architecture, as well as some anti-patterns and best practices for generally each layer of the migration. So
right.
We'll talk about the services.
Cloud can be very profitable for your business, for your project. Even it doesn't matter if you are a manager or an engineer, you still can benefit from cloud flexibility and power, and that's for sure. But there are many places to make a strong, solid mistake and harm yourself. So listen for Raul because that will be a very important point to avoid.
Yeah, hopefully you'll learn from my mistakes.
Yeah, it's much cheaper.
That's much cheaper. Exactly. Just want to thank the sponsors. So today we're not going to use Gitpod. Next session we'll take a look at it. Gitpod is our kind of preferred tool for showing people how to use technology. If you haven't used Gitpod, it's like Visual Studio on the cloud. DataStax, obviously, for helping us put this together, and my company Anat, that's been very supportive of me doing these type of things. So without further ado, what is architect? I'm wearing a t-shirt with an architect. I want everybody that's watching this to ask, what do you want to do with your careers, right? Well, at our company, we build architects. We build the builders. We build the chief builders. So our company is a platform architecture firm. We create systems, we create platforms. That's the verb. But we also create architects. We transform engineers, coders into consultants and architects. So if you're interested in becoming an architect, join our company. Love to have more smart people.
Yep.
Always hiring. We love scalable, fast data. Stuff that we work without data stacks, which is harder, and with data stacks when it's easier. Basically, the fast data world encompasses Cassandra, Spark, and Kafka. We work with all of those technologies, and then we have to know a lot of other stuff. So what you'll see in the series is actually what we have to help our clients think about outside of the data platform in order to make the data platform successful. Because everything's connected, right? Let's go back in time a little bit.
Yeah, sure. I have a time machine right behind me, so I can easily bring us back. Let me moment.
Let's go back in time, maybe 30 or 40 years ago, when the internet was starting off, right? And we're going to see how the evolution of the internet has also brought us to the cloud today. So shift 1.0, right? The first shift was going from physical servers to virtual machines. Now, most, technologists today, they take the cloud for granted, right? Oh, I need a virtual machine, just make it. Oh, destroy it. Well,
yeah.
before Amazon made it a commodity, very few people had access to VM technologies that was that good. And on top of that, servers were physical servers, right? They were physical machines. And so when we went from physical to virtual, I was so glad because I used to run a hosting company and I would cut my hands building servers. Yes, exactly.
I can imagine. I would add one point, what there actually were two great changes, physical machines to virtual servers, and the second one, hardware networks to software-defined networks.
Yes.
Also very important.
Absolutely. I mean, the ability to do routing and subnets and VPNs all through software now, we take that for granted too.
Yeah.
Thanks for bringing it up. Absolutely. It's an amazing technology today, which we'll cover when we talk a little bit about infrastructure as code, because now everything is code.
Yep.
Right? Everything is code. Now, when things went from physical to virtual, the software did not have to change that much because the software was just literally lifted and shifted from an operating system running on the physical device to the virtual device, right? No major work was involved. The next shift was basically right before we got to containers, which is auto-scaled VM-based services. Now, this included things like actually Kubernetes. Also, when initially Kubernetes was coming out, you could subscribe to certain services that scaled your infrastructure for you, and it would scale it down if you weren't using it. But it was still, the architecture of the software was about the same, right? You had to make sure that your software was stateless, meaning it didn't have any data in your deployment of the code. And you have to make sure your database itself was scalable, but your application layer could scale, out and scale that back in. Elastic Beanstalk, which I think is still around, was one of the first services. And then Heroku started to come around with their own services, which actually led to the container revolution. I'll get to that in a second. But this shift got people to see the value of the cloud, which is you can scale out when you need to, and then scale back in when you don't need it. And I was just speaking to somebody earlier who worked in the financial industry. They would have to manage a transaction for petabytes of data, but that process only took like 4 hours on a big cluster, and they could just turn off the cluster or destroy the cluster after that. And they saved millions of dollars a month by doing that. Right?
Yes, exactly.
Huge.
But that's not only about the direct losses or direct costs. Those we can calculate, and those are more or less obvious. But there are so much more losses what are hidden from people. For example, a research and development team of a friend of mine, needed to have some virtual servers to make some experiments, try to find better solution for their business. And they were not able to get some virtual machines for them just directly. They have to request for them, and it was a huge and slow corporation. Like, you know, many monsters can be very slow as they are getting huge. They wait for the group of machines to make an experiment for 8 months.
Wow.
What were the costs of these slow advance? I don't know. No one can calculate. Maybe it could have been billions of dollars.
Yep.
No one knows, and no one can calculate. Speaking, yeah, please.
No. What you're talking about is lack of knowledge sometimes causes that too, right? It's the mistakes.
Yeah. And exactly for auto-scaled virtual machine-based services, that I remember the first moment I've seen it, it was like a really magic. I mean, the coming of virtual machines switch at the moment when you can wait for new machine for your disposal from really for a year, because you could have been waiting for a new server, physical server, for a year or maybe more. And now it was normally much faster time, but you still have to think ahead, plan ahead, make some things to make this happen. And with auto-scaled virtual machines, it just appears when you need it, disappears when you don't need it. And it works like amazing. That I was so excited first time. It was auto-scaling at AWS EC2. It was just amazing.
Yeah. And before we go to the next one of the pitfalls for auto scaling was people did not have any guardrails.
Yeah.
So sometimes they would have a really big bill.
Oh yeah. Especially when you configure scaling out, don't configure scaling in, and one morning you just wake up to get a bill of dozens of thousands of dollars for a training environment.
Exactly. So next shift is, we're kind of in the middle of this right now. Kind of in the middle of this and the next shift that we'll talk about. But going from a virtual machine to the containerized world has been, I would say, the last five to 10 years, I would say, probably more closer to 5, where everybody knows, well, I don't know if everybody knows, Docker is kind of used everywhere now. Kubernetes is used everywhere now. But as late as, I don't know, 3-4 years ago, we were still debating, is it Kubernetes or is it Mesos?
Yeah.
What container orchestrate, or is it Swarm?
Yeah.
Well, now Kubernetes has won, right? Everybody uses Kubernetes. But containers, they've been around for a long time, and Google's technology with Docker, combined, is what we now use. Most platforms are built on top of Kubernetes. And where did Docker come from? Docker came from some people that wanted to build a Heroku clone that could run any technology.
That is
because
interesting.
Heroku initially would only allow you to run like Ruby and like
Python, I believe.
Python, maybe PHP. I don't remember exactly. And I remember they had very limited selection. But now they can actually run a Docker container for you.
Yeah.
Basically, anybody can run a Docker container for you. But Docker came out as a goal. The goal was to make a standard way to deploy software. And wow, what a powerful concept. Everybody can get their mind around this, where you used to have to run an operating system just for your app on a virtual machine, just for one component of that app. And that would be so much bloat. Versus now with the container, when you containerize it properly, right? You can have a container that's bloated, that's like a gigabyte, or you can have a container that's like 20 megabytes. And the same thing applies when you're writing serverless code too. But ultimately, the container allows you to make software that runs side by side other containers, and it leverages the same operating system. And that's huge. That's huge because maybe some of your application needs to come into being and then do its work and then go away. And you don't necessarily want to build up a virtual machine to do that, right? You just want to run that thing and have it done and go away. And you can use the same hardware to run thousands of processes, right? So that's huge.
Yep.
Containerization allowed people to really maximize their hardware
Yep. And
potential.
meanwhile, doing many things much faster. I remember first time I joined for my first project in Germany. Just setting and deploying a project in the development environment for every new developer joining the project. It was almost 2 days just to set
Yeah,
up a workplace. And
yeah,
after our migration to Docker, it normally took 15 minutes.
15 minutes.
Yeah, 15
Yeah,
minutes.
that's amazing. And you know, Gitpod runs on containers. So now I would say when we have to show somebody like a new team member how to do something, um, we even have some of our actual environments on Gitpod where literally it's like we send them a URL and we say, here you go, right? And so that's all powered by Docker. You
Yep.
don't even have to have Docker running on your computer. And I think a lot of the Kata Coda is all running on containers, right?
Yep.
So huge. I mean, I would say it's like a stepping onto the moon type of shift, right? Going from virtual to container was a huge transition, and we're still here. People are
Yep.
still trying to containerize their applications now. Now, the next shift is serverless architecture. And before I do that, I'm gonna turn on the lights because it's getting a little dark in here. Give me 1 second.
Okay. Meanwhile, I can say what. Just a little disclaimer. For many years, I was an opponent to the serverless approach. Now it's changed, and you will see it soon. But in general, for many years, I was very against serverless architecture for real, and I know many people who was with me.
I I was also against it. You're not alone, Alex.
Yeah,
I I fought it a little bit until I found the Jamstack.
yeah.
Once I found the Jamstack, I was sold. So we'll talk about the Jamstack in a little bit, but I totally get it. And I'll even explain why did I not like serverless architecture. Well, serverless architecture requires you to think in a different way in which you don't think about the hardware at all, right? You just focus on your data model, your data processes, and your business logic, and your presentation layer. You don't care about the infrastructure at all. And being a hardware geek, having run a hosting company, I felt like I wanted to control these things. And so I realized that the reason I didn't like serverless architecture is because I was losing some control. And the reality was but I was also gaining a lot more. In the same way that physical to virtual, we lost some control, but we gained a lot of freedoms. The same thing from virtual machines to containers. When we're going from containers to serverless, it's a similar type of shift. Now, just like going from physical to virtual to containers, and containers to serverless, each of these transitions require us to make a slight change in our architecture, in this case, a big change. And we also have to think about a few other things. Because everything is running on other people's hardware, when it comes to security, when it comes to logging, when it comes to monitoring, we have to think about those things unless the provider of the platform gives that to us, right? But truth be told, going from a microservices environment where you are running your software on containers to a completely serverless platform, that transition requires you to do a heck of a lot of work in
Yep.
order for you to be able to test that software, let alone scale that software without it breaking. And we'll cover a little bit of that as we go into what to avoid. But serverless has a lot of potential because what I mentioned earlier, you don't have to worry about hardware. You
Yep.
don't think about it. You
Yep.
focus on your business, basically, right? And a lot of clouds offer serverless. So, Amazon has its version of serverless. Azure has its version of serverless. Google has its version of serverless. And when we say serverless, it's the concept of functions running in the ethereal cloud, meaning instead of making a piece of software and saying, go run this for me and scale it for me, you focus on the function itself. Maybe it's an API endpoint, right? And you say, what does this API endpoint need to do? And you just write that code and you deploy it, and then it scales automatically, magically. And there's a lot of other things behind the scenes that it does for you, but that's not it. Serverless is more than serverless functions. Serverless also includes serverless databases.
Right.
Right? Serverless APIs, serverless streams, serverless storage, serverless, you name it. Anything that you could be using to build your application, now you don't have to think about the infrastructure. There still are services where you say you want some service, but you have to pre-commit to some hardware, right? So like the difference between Elastic Kubernetes service on Azure versus Fargate, right? EKS, you're spending money on machinery, right? But Fargate, you deploy your Kubernetes application and it scales it for you, and you don't worry about the hardware because Fargate is serverless. So serverless is a loaded word. And we're going to talk about serverless data, and we're going to talk about serverless applications, and we're going to talk about how Astra makes it easier for you. So Shift 4.0, it's coming and it's here. So it's like that movie Tenet, right? Both of these are coincidentally happening right now, right? The shift to containers and the shift to serverless is happening right now, and they're not mutually exclusive, right? You can do both. Yep. You can do serverless containers too.
I would bet what most of the companies now are on the hybrid deployments.
Yeah, and that's what we're going to talk about, is what does that look like, right? What does that transition look like? Because it's very few companies can be 100% serverless right now, right?
Yep. That's not, you see, there are many different businesses with very different requirements. I know people, one online ads project, very big, they drop it even Docker, because they have such a huge pressure and they need such a high performance. They want to go on bare metal, very bare metal, because they require highest of highest possible performance. But I believe in our case, in most of the companies' case, it's better to maybe buy a couple of more servers, but to think on a little bit different approach indeed, with maybe serverless or at least getting close to it, because the flexibility what it gives to engineers and to businesses, that's incredible.
Yeah, and when we're talking about serverless functions, there is a use case for that, right? Maybe you want to have an API that wraps another API. Maybe you want to have an asynchronous process that maybe sends a message to, let's say, 1 million people, right? Like emails or notifications. Those things are great for that. Serverless functions are not great for long-running processes, right? That's what containers are for. Containers can do that for you.
Yeah.
Serverless functions are not for data processing.
Yep. I would say there are two big limitations to consider about serverless functions. Well, there are more limitations, but those are very important. First of all, if you still, I don't think what using serverless functions like AWS Lambda is a best practice to use them as something answering direct calls, blocking synchronous calls of your clients. If you want to have a perfect response time as low as possible, then serverless functions may be not the best scenarios. Second, if you go with serverless functions, and there are functions what require like databases connection, especially if you are, for example, going to connect to Cassandra. Cassandra driver is extremely smart, but it takes time to start because it has to receive information about the cluster state. All of this. So there are a lot of considerations to consider, reconfigure, switch something off, switch something on. So if you don't know what you are doing, you can definitely run into troubles. So learn first.
Exactly. And the what I'm trying to get you guys to see here is thinking about the serverless architecture in these different layers and understanding what they're good at will help you decide what to use, right? So we're going to talk a little bit later about, what does a good processing engine look like on Amazon versus Azure, right? And what does that have to do with the serverless architecture on those clouds? But basically, I would categorize them. There's more categories, but I look at them in the following ways: functions, containers slash microservices, and I put them in the same kind of clump because, like, you can write a Java microservice in Spring Boot, and technically it's a virtual machine. So, anyways, containers and I would say containers and microservices in the same area nowadays because you can deploy it with services like App Service on Azure or Heroku or Vercel, where you are writing code and it's wrapping it in a container for you and then it's scaling it for you. Processing engines are different in terms of the serverless world than, let's say, if you were to run your own Hadoop cluster versus using Amazon EMR, right? Or to make your own a Spark cluster versus using Azure Databricks or Amazon Databricks.
Right.
And I think Databricks is also on Google as well. Then there's serverless content or endpoint delivery. Now, this technology actually has been around for a while.
Yep.
As far as I can remember, there's Akamai. I don't know if they're still around, but Akamai was there in the beginning of the dot-com boom, content delivery network. Well,
Yep.
You know what? They're still around. They're still around.
Yeah.
And they're very important in terms of scaling applications, especially when we're talking about the Jamstack. And then finally, there are serverless databases and APIs. And API is a loaded word. So what I mean by that are data APIs, persistence APIs, basically APIs to put data and get data back. In that category are application areas like headless commerce, headless content management systems, which are basically APIs, right?
Right.
And to a certain degree, these are databases that have been exposed to the world as a REST or GraphQL API. And that's actually where Astra sits. Astra sits in this area. Now, why do we want to get to this next state?
Why?
That's why. Why should I change? Well, I'll tell you a little story. I'll tell you a little story about how we are doing it. Small application, but it's growing. So we have an application, internally we call it Graph, but basically it's a knowledge graph. And Cassandra.link is actually powered by it. It's just one site. There's probably 15,000 hand-curated links, but it's made up of a combination of now serverless components and virtual machine components and container components. So it's an application in transition, just like most applications are always going to be in transition. And we had made this initially with containers because containers were already out there, and it worked fine. And then we started to have to maintain containers, and it became a pain in the neck, and we don't want to do that. This is about 2 years ago when Astra started to come into the scene from a beta perspective, and it was interesting. So we said, well, let's see if we can transform this. And in 2020, we wanted to go by taking our current API, which was powered by a bit of Cassandra and a bit of MySQL with the PHP application, and basically putting that data, mirroring the data into Astra so we could have some legacy support, and then making our own APIs and running those APIs on containers and scaling them on some sort of service, right? That was the original plan, okay? And last year, we already had our API, our front end on serverless platforms like Netlify and Vercel, right? This area right here, I don't know if you can see my mouse, this was already taken care of. We were just in the middle of transforming this. Well, this is where we're going this year, because Astra actually gives us an API layer so that we don't have to maintain this. We don't even have to have this API layer. If the Astra is going to take care of it, why do we need to do that, right?
Yep.
And as you can see, the transformation from here using containers on machines we were managing to this layer. We don't have to maintain any software. Sorry, any hardware.
Yep.
All we have to do is write code.
Well, software as well.
Software.
Yeah.
That's what I meant.
And hardware and software both, and also configurations, updates, security patches, and so on and so forth. You know, like one of the favorite phrases, like there is no serverless, it's someone else's computer.
So, exactly.
And but okay, yeah, technically that's correct. But what does that mean? If it's not my computer, right? It's not my headache to maintain it, support it, patch it, reboot it, take care of it, remove disks, put new disks, and so on and so forth. So, and in the beginning, when I was young and wanted to build everything from scratch, like I believe most of the engineers in the very beginning, I thought what serverless is a bad idea because it's not my computer and therefore I don't have control over it. And now I understand what those people are taking care, and they are taking my headache to themselves, so I can think of what to develop next, what are the needs of my clients, and how to make it the best way. So they make they make me free and more able to take care of my clients. So that's what I love now.
Yeah, and what it does, you know, for us is that right now it's a simple application that we use internally, and we publish knowledge bases, right? We use it and we make it because we couldn't find anything better. And although I've tried to look for software that does this for us in like the speed that I want, I haven't seen it. So, but the thing is, you know, as we use it and we start to publish more sites, right now Cassandra.link is getting a lot of traffic, and you know, soon we're going to be publishing one on Spark, similar to Cassandra.link, but it'll be around Spark, and we're going to be publishing something on Kafka as well. So as we start to build out these sites off of the same core infrastructure, right? These sites are going to be kind of like tenants, and they're going to have different needs, and those needs are from the users of these sites. We want to spend time servicing the needs of the users rather than servicing servers.
Yeah. Server is to serve me, not me to serve server.
Exactly. So we save so much time with Astra. And this is why I'm going to hand it over to you to talk a little bit about Astra.
Yeah. So Astra is a very interesting story. It all comes originally from the time then Facebook first met very big size problems. Facebook was one of the first companies what reached really the level of incredible amount of data, incredible amount of transactions, and so on and so forth. And they needed new and better solutions. Then two engineers of Facebook created, let's say, first prototype of Cassandra. Cassandra is a distributed, decentralized database which was created with three purposes, but one general idea. The idea is to be able to handle pressure what hugest companies taken, and the goal was to create a database what will be able to handle any amount of data under any pressure, whatever billions of queries per second it gets, and meanwhile available globally, because for many years companies weren't truly globally, and only businesses like Amazon, like Facebook and others, the first or maybe not the first one, but first those who got this as sharp, as hard as it was for them for real. And here comes Cassandra. Cassandra later was actively developed by DataStax, and it became an Apache Software Foundation project. And it's a really great database. Version 4 was recently released, and Cassandra powers businesses like Apple, and Apple has one of the biggest Cassandra deployments in the world with around 200,000 dedicated Cassandra servers. That's quite a number. Netflix, hundreds petabytes of data. and so on and so forth. So Instagram, for example. So Cassandra is proved to be very successful on this line. But yep.
I tell people, Alex, that if you're using Cassandra, it's like the last station on the train track.
Yeah.
Because there's no other database that can scale that big.
Yes.
And that's open source.
Yes,
you know?
right. I would say what there are some interesting solutions from AWS or Google Cloud, but they are bound to one single cloud provider, whether for AWS or GCP. But at this scale and open source and cloud agnostic, so you can deploy it everywhere, there are basically no competitors. And meanwhile, what I like the most, it's developed by a very strong community. So as I said recently, Cassandra version 4 was released. But who gave the biggest effort and who made the most of the changes for it to happen from version 3.11 to version 4? Apple, Netflix, Instagram, DataStax, and many other great companies. So it's a truly teamwork. Some of them are even competitors, which I find quite funny. They're competitors in business, but they're developing something together. Isn't that cool?
That is cool. It's amazing.
Open source makes us better. So
absolutely.
With all these things, Cassandra is truly great, but there is always a price to pay. On the scale from bicycle or skateboard to a Boeing or Airbus, Cassandra is very much on the Boeing side.
Yes.
And if you first see a skate or a roller or a bicycle, you can get an idea how to use this vehicle. And maybe after a couple of minor falls, you will be able to ride and smile and shine and be happy. And if we speak about complicated distributed solutions, that is going to be a very different story. So with Cassandra, first you have to speak quite a lot of time to build proper infrastructure, learn how to use it, then deploy things, then run into troubles. Why? Because you didn't learn data modeling and you didn't know what you need to learn it in advance before trying to do something in production with your client's data. So, I like Astra DB because idea of Astra DB, it's still the same Apache Cassandra, or it's very heavily based on Apache Cassandra. There are some changes. But it's still platform agnostic. So when you create an instance of Astra DB, you can decide if you want to use AWS or GCP or Azure. That's for you to decide. And then that's still the same Cassandra with all of these powers. But now you don't need to hire a dozen of best database architects and another dozen of best operations team people to take care of your deployment, because DataStax will do it for you using power also of AWS or Azure or GCP. Teamworks makes best work. So everything what I said about Cassandra is also applicable for Astra. With a global scale, zero lock-in, you don't lock to AWS or Azure, you can migrate, and many other things, but also, especially for young projects, for startups, for people who just want to build something, but not really sure how it will work in the future, Astra DB has an incredible free tier. So if you go not with a really heavy production workload, if you have less than 30 million reads, less than almost 5 million writes, and you consume less than 40 gigabytes of disk space, it's free and you don't pay, and we don't even ask for your credit card. That's quite cool.
And that's a lot of data, by the way, right?
Yeah.
It's you don't use Astra or Cassandra for your data lake. You're not going to put petabytes of data in here, because Astra and Cassandra, you can use it for a data lake.
Yep.
Right. But the truth is you're using Cassandra because it's the biggest fast data, or it's the fastest big data database. And it's, relatively speaking, it's a much easier to transition into Cassandra and Astra because it has CQL, but it also has these other cool APIs like GraphQL and REST. But you're not going to dump petabytes of data into it for analytics. You're going to use this for transactions. So 40 million, 30 million reads is a lot of, reads.
Yeah.
It's a lot.
Yeah. So that's really like, that's a very generous offer. I believe it in some places better than AWS free tier, for example, which is, by the way, very good.
Yeah, definitely. And can you talk a little bit more about the Stargate APIs? Because that's one of the biggest draw for me.
Yeah, that's a great thing. Do you have a slide about Stargates?
Yes.
Perfect.
Yep.
Thank you so much. I was trying to answer Baburao Bol question, but sorry, I will first speak about Stargate because it's also a game changer. So I will tell you a story of one of our friends, I could say, a company known as Yelp. Yelp is quite a big company actively using Cassandra, but as I said before, Cassandra is not so simple thing to use, so you have to learn a lot first. And they have a lot of developers, and they want their developers to be creating things and solving business problems and not learning something new all the time. Then you hire new developers or teams changing and so on and so forth. Idea was to try to be able to use data layer, try to use database as a Cassandra, but with no need to learn Cassandra query language. And on another point of view, you see, Cassandra is a schema-full database, so you first have to create schema, then store your data there. And there were some projects they wanted to use document API, like in MongoDB, or there were some projects they wanted to use just throw data to database using REST, RESTful protocols, and they don't really needed any kind of Cassandra query language or any kind of other language, any kind of document API, just throw data in form of a REST and get it back by the key. And can you imagine what would operations guy ask, what would operations guy tell if someone tells them, okay, now you need to run a Mongo cluster for us and whatever cluster for us and this and that. And they are like, okay, guys, we are already busy. We don't want to do it. We want to install database, every database you want to try in the world. Do you know how there are many databases? Around 400. We want to install, like, there is your Cassandra, learn how to use it. So both sides were quite unhappy. And solution was found in the special data proxy API. Proxy API is the way, so that from one side you have multiple APIs and from another side you have single database. Idea was to give the developers every API they want to use. GraphQL, REST, document, still give them ability to use Cassandra query language, of course, but to give the operations team still to maintain one single database cluster, not a dozen of them, right? And that's basically the idea of a Stargate. It's an API proxy which gets your requests in a form of documents, REST calls, or GraphQL calls, converts them to SQL and executes as a part of a normal Cassandra things. Now you don't have to learn SQL using Stargate. You can use just for you store documents like you store with Mongo, or just have a data layer based on REST, so you can work directly with that without any document API or Cassandra query language. It also supports GraphQL, which is quite cool, by the way.
Yeah, and what I like about Stargate, under the hood, it's really cool technology, and we don't have to talk about it because Cedric is going to talk about it, I think, tomorrow or the day after on ApacheCon. Look out for that. The cool part is that I like using CQL, right? And a lot of my colleagues that are younger, newer, and they came in from the Mongo plus the MERN stack, right? Mongo, Express, React, and Node stack, right? They can use the document API, and I can use a CQL API, and it's the same cluster.
Yep.
Right? That's what I like about it. It's amazing. And in our architecture, we if I go back to this diagram right here, most of what we were really doing with our APIs were basically REST calls that were save this document and get this document back, right? So instead of making our own APIs, converting that into CQL, or even like I know Cassandra can store data as JSON and retrieve it as JSON. Rather than having to do all that, I can just use Stargate, right? Stargate, which is part of the Astra DB. And what is useful for us with Stargate is while the apps are talking to the database using these APIs, we can have Spark to do analytics on that same database using a more native, CQL to grab that information. So at the same time, right? That's the cool part. At the same time. Awesome.
And you can do it and deploy it and develop it at the same time because it's not you who takes care of the database cluster. Exactly the benefit.
Yeah, and it's got a great user interface where you make your databases and you basically will immediately get a Swagger endpoint to take a look at your APIs, how to add, delete, CRUD operations on that. And if you want to, you also have a CQL SH where you can go and check out what's happening on your database if you want to. And finally, there's health and monitoring, and you don't have to take a look at that for the most part, unless you notice that.
Yes. No. One of the one of the most oftenly forgotten idea of the cloud, like what makes cloud, why this service is a cloud and this one isn't. Well, what people forgot most of the time, what's the quality of the cloud? It's self-service. If I need to create something, if I need to use something, now again, we take it as a given. You just, if it's on Saturday night, you want to create a new database, when you go and create a new database, and that's, or you can use API to create a database if you prefer command line tools, of course. But again, people who are long time in this business remember very well when they have first to wait for Monday and then make a couple of phone calls and email order, or sometimes in some cases even mail order. I mean, like the paper, can you imagine? And yeah, that's one of also was a big challenges and changes of the clouds.
Yeah, and one thing you mentioned, and we'll talk a little bit about it when we talk about DevOps, is that Astra also has a provider for Terraform.
Right.
I've also seen some examples using Ansible to create databases. So if you want to be able to do this automatically as part of a DevOps process, you can also do that.
Yep. I have to admit what Terraform plugin is not fully completed yet. So it works in general, but there are some places for improvement. It's quite a fresh tool. I'm considering to change some of my plans and join a team working on Terraform plugin, because it's very important for us, I believe, to make Astra manageable via Terraform.
Yeah, and there's I'm trying to remember who published it from the DataStax team, but there's a set of really good Ansible examples as well, which basically wrap, I think, the DataStax DevOps REST API with Ansible, and it's pretty useful, I think. So yeah, Astra is great. Check it out. And by the way, before Astra, right? And I would train people on Cassandra, and I've trained people on DataStax. I would say to people, don't use Cassandra to be cool, right? Because it's hard. You really need to use it. You really need it in order to use it, and you have to learn a lot to do it. After Astra, I tell people to use it via Astra all the time, because it's actually, not only is it easy, it's more scalable, and if your application does scale massively, you don't have to worry about it, because you know that Cassandra can scale. So it's kind of getting the best of both worlds. So and you don't have to use Astra for a big database. You can use Astra for a small database too, right?
Yeah, especially you see, there are 2 points. First, as said, Cassandra requires qualified personnel to take care of. And second, it's anyway going to be at least one data center of at least 3 servers and so on and so forth. And if you are going, if you don't know if you will have a lot of data or not so much, that may be an overkill. And with Astra, you pay exactly as you go. And if you don't consume a lot, you don't pay at all. So for starting projects, for doing test projects, it's just the perfect thing, like really perfect thing. And it's absolutely free. Again, we don't ask for your credit card as long as you don't consume over than millions and millions and millions of requests. Another point of view, it's not exactly the topic of this workshop, but Raul touched really like a very pain point of me, of my professional experience. I've seen many times in many companies using some solutions not because they are good for their use case, but because some other cool companies using this approach. Hey, Google uses microservices, so we will use microservices too. Hey, come on, you are not Google. You are not Google. You have 50 people in your team. Microservices, in your case, will solve which particular problem? I don't know, it's just cool. If it's just cool, then do it as your home project, but don't touch your business, which is for to your customers. That's incredible.
There's a good article by Segment. You know, Segment, I think most people are in the marketing world know about it, but they're an analytics company related to customer data. They're a customer data platform. They had a good article. I think it was them. They said, we stopped using microservices, and here's why. And I wish somebody had written that article much earlier, because everybody that's gone to microservices has done it for the wrong reasons. You know, and their reason was microservices made their platform slower because what they were trying to do with information didn't fit in the world of microservices. Sure. It was an analytics platform. And so they had to go back to not necessarily a monolithic system, but they had to go to a different architecture, back to closer to what they had before. But anyways, we digress. That's a different conversation for a different day.
You know, many developers remind me fashionistas. They like see the top model fashion wearing, I don't know, a bag or something, a dress. And everyone now runs and want to have this bag and this dress. Don't be like that, please. Be better, understand your needs and your ways to solve your problems.
And one last thing before we hop back into the kind of the cloud planning topic is that people say, how long do you think Cassandra is going to be relevant? They ask me that question, right? Ooh. Is it just fashionable? And here's my evidence. Whatever you said, right? Spotify, Netflix, Apple, Walmart, I mean, name it. There's a bunch of companies that use it. I said, these companies are not going to stop using it. Number two, why would Microsoft make a CQL compliant API?
And AWS, too.
AWS make managed key spaces for Cassandra.
Yep.
Why would there be two separate companies that make a C++ version of Cassandra? Completely different technology that does the same thing as Cassandra, right? They wouldn't do it because they're having fun.
Yeah.
Right? They do it because there's a potential of business that needs this big data database that's fast. So Cassandra's not going anywhere.
Yeah, that's for sure. And you see, many people not yet understand, not really realize it yet, about how the world of data will change. And the point is, it basically doubles every couple of years, and more companies realize what in order to succeed, they have to become data companies, data-driven companies, become data-driven or die. And to make reasonable weighted decisions based on data, you're going to have a lot of data. You know what? Machine learning doesn't work on a small data sets, because there is not enough information to learn the model, and it goes the same for the data-driven companies. You need to have a lot of data. So more and more companies will have to store more and more data, more and more globally, and basically there is one best way, like type of art solution for this.
Yep, absolutely. Good discussion.
Yep.
Yeah, so finally to kind of put the nail on the coffin, right? Why use Astra? Well, for us, it's let's just focus on the features, focus on what matters for users and for us. And generally, we do want to become serverless, but ultimately, our time is valuable. People don't understand this. I think you know this, Alex. People are the most expensive thing in a business, the most expensive thing.
People,
And
yep.
the cost of labor is very expensive. You're gonna save $15 a month or $100 a month for what, right? Like one person's time, even in the cheapest rates, right? Like that's a lot of money to waste building something if you can just buy or subscribe it. Especially if it has to do with bigger and bigger scale, where you have to have more and more people, right? It doesn't make any sense. So using serverless is actually about being smarter business people for us, right? To leverage our time better. And that's where I think ultimately management can see the value of serverless is your team can do more intelligent things, right? And let somebody else deal with the boring things, basically. So let's say you make a decision to go to serverless database like Astra. Well, will it work on my cloud? Well, yes, it will work on your cloud. Uh, on Google, some of the complementary tools would be obviously Kubernetes, right? Google made Kubernetes. You can run whatever API or app you want on top of Kubernetes. You can run Spark on Google Data Proc. You can run Google PubSub, or if you want to use Confluent Cloud, you can use that. There's also something called Google PubSub Lite, which is a little bit closer to Kafka. And then for controlling and managing things, especially with Spark, I like to use Livy. And Google has Airflow as a service. We'll talk about Airflow in the next talk, but Airflow is an amazing tool. You don't even have to run your own Airflow. You can just use Airflow with Google Composer. That's what they call it. So at the end of the day, if you are deploying Astra onto Google, you can keep your APIs on Kubernetes, and you can keep your Spark on Google Data Proc, or you can even use Google Data Flow. And if there are other technologies on Google as well, I'm not showing them here, but there's technologies like BigQuery and those have benefit. They're data warehouses. That's a different goal, however. Well, what about Amazon? What if you're on Amazon? Well, Amazon has EKS, and they also have Fargate. So you can deploy your apps to Fargate, where they will take care of the scale of your Kubernetes. And similarly, if you decide to run Airflow, you can run Airflow and Livy on Kubernetes as well. So you'll see this trend, right? So Kubernetes is everywhere. Guess what? Astra runs on Kubernetes, right? So there's a theme here, right? You can use some hardcore technologies like Amazon EMR, which were built for basically analytics. They're generally serverless. They scale up and they scale down as you need to. You can use Kubernetes to run anything custom or off the shelf. And then you can use a service like Astra to put your data and to retrieve your data. And because Astra is scalable, you can have transactions happening on one end of the applications in real time. And you can have analytics, batch and streaming analytics happening on the other end. And Astra is going to scale because it's a translytical. Cassandra is a translytical database, right? It can do transactions and analytics at the same time. Normally, if you were running your own cluster, you would have to run 2 different data centers. With Astra, you don't have to worry about it because, well, Astra's built to do both for you. It can do reads and writes, and it can do reads very, very fast, depending on what you're trying to do. It will handle the request for you in the fastest way possible. Azure, same thing, right? You got, they have HD Insight. They also have Databricks. I think you can get Databricks on every cloud now. They have their own version of Kubernetes called AKS, Azure Kubernetes Service. And as with any Kubernetes, you can run anything on Kubernetes, right? All you need to do is to get the Helm chart, and bam, it'll work for you. So you have made a decision. You're going to move some part of your application to serverless, or you have already moved some part of your application to the cloud and you want to transform it into a service application. How do we go about managing that transition, that migration? Well, first you have to take inventory. Okay. We at Knot usually break down every system, every platform into the following categories: interfaces, software, data, and systems. Interfaces are what people use, user interfaces, or it could be APIs, application programming interfaces, right? Software, where does the logic live, right? Or is there any particular middleware that needs to do some actual computation or processing? Data being databases, files, streams. It could be other APIs. So for example, Astra would eventually fall under data, even though it's also an API. And then finally, systems that are self-contained, black boxes, platforms or frameworks that we have to interact with outside of our system. If you have a collection of systems, you'll have common systems, for example, that they're dependent on. So getting an inventory of everything and visualizing it helps you see the dependencies. Because if you're going to move one part of the application and it's going to affect another part of the application, you need to know that beforehand. Now, if you take what I just mentioned, right, interfaces, software, data, and systems, and you ask, like, at the end of the day, how does this add value to the business? It's usually in the following categories. There's applications that are being, they're being interacted with. There are services that may be running in the background, or it could be, interactive APIs. And then these are what is actually the real application itself. Then in the background are data operations and DevOps. Data operations are things like managing queues, managing databases, how are the stream and batch processing running? Is there a pipeline that needs to be run? And then all of that is supported by DevOps, right? You have your applications powered by services, powered by data operations, powered by DevOps. And every system has some component of this. Even if you don't have it, you don't have it. So at the end of the day, when we talk about migrating something, you have to take an inventory to understand what you have and what you don't have. Because if you don't map it out, eventually when you go to the cloud, or eventually when you go to the serverless cloud, and you don't have a DevOps system in place, and you don't have a data ops system in place, you're gonna face that pain later on, right? So you're gonna hear me say DevOps, data ops, GitOps a lot, because that is what actually is the underlying skill or practice that makes a cloud platform work. It's the operations. Even though you're not managing your servers, you're still responsible for your data. You're still responsible for your software. Well, who's going to write the software and get it into staging and testing and production, right? You still have to do that. Right? Amazon is not going to do that for you.
Yeah.
Right? They may give you the tooling, but you still have to do that. So what I say is start with the bottom of the stack, right? The bottom of the stack is, what is all this stuff running on? More than likely, you either have on-premise, or you have your own, you're using, on-premise with VMware, or you're using one of the public clouds. You start with the bottom and you take inventory. And you say, what do we use? Then you may or may not have an orchestration layer like Terraform, which is one of the cloud agnostic infrastructure as code. You could also have Azure resource management templates. You could have CloudFormation templates. What is it that you have? You may not have it, but you should say, I don't have it. We don't have infrastructure as code, right? One layer up, so this is kind of the DevOps aspect of things. One layer up are the systems and components that make up your data, right? Are you using a database, an index? Do you have any Spark processing? Are there any systems that need to rely on the data for data requests, for queries, right? Is there a data warehouse component that you have to think about? So, everything is connected. I would say if you make a picture of your platform and you can start with your DevOps and build your data ops on top of it, and then on top of that, you can define your user interfaces and your APIs, you have a fairly complete picture of your architecture. The first step is you have to design. Even if you don't have a design, you have to draw this picture. And every architecture book I have read talks about that the best way to see the system is to draw it out. You don't have to be like really good at like whiteboarding. You could use, you could use whatever tool you want. But if you don't put it into a picture, it's extremely hard to know how things are connected.
Absolutely.
Now, each component, right? You have to think about how are we going to go from our current state into the next state. So in this example, is basically this is the real infrastructure design, by the way, right? This is we're using DigitalOcean for some things. We're using AWS for other things. Azure for backup, Google for backup, and then IBM and VMware. We're just playing around with we're using natural language understanding API here. And then VMware, we're just kind of playing around with it to see, on-premise, how would we do this? But what you notice on top of the infrastructure is actually we're trying to use managed things, right? So managed services for Astra, for Confluent Cloud, for search stacks, for Solar, Algolia, Google Firebase, and then DigitalOcean has a kind of a MySQL service that we like using. Managed functions, we're using actually a system called Vercel. Vercel takes our code, our Node.js code, and wraps it with some layer and deploys it as a serverless function somewhere. We don't even know what they use, actually. We just know that they're serverless functions. And then finally, there are some things that we have not converted into containers yet, into serverless functions yet. And so those run on Docker and Kubernetes. And so we're using a managed Kubernetes on DigitalOcean to take care of that for us.
Yep. Raul, I have a great question in the chat I want you to answer.
Sure.
Why are you using so many cloud providers? Any specific reason why someone would do it in the real world?
Sure, that's a really good question. There's two reasons. One, certain things are good. And by let's say Google Firebase, great authentication system, right? We don't have to build out. I mean, I guess we could have used another vendor, but we like using it. We like using the Firebase ecosystem for authentication and from some of the profile storage. And we kept using it. Algolia is one of the better indexes for making like quick lookup on your user interface. So we use it. Search stacks is hosted Solar. We actually have been using Solar forever, and we like the power that Solar gives us, but we don't want to manage it, so we use Solar. So eventually, all of these things run on these different cloud providers, right? There are also specialized services that we can't get elsewhere. So technically, Azure and AWS, they have their own cognition services for machine learning around natural language. Well, IBM has the best ones because they bought out a company called Alchemy. So that's why we use IBM for certain things. So every one of these public cloud providers has something we like from them that is the best of what they have to offer, right? Amazon has S3. There's no better file system in the world than S3. End of story, right? It is if you put data onto S3, it is globally available, right? Yep. Azure can try to compete against that, they're not going to be better than that. Google can try, but they're not going to be better because they've been doing it for such a long time. So one reason is specialization. They do something really, really well. They offer it up as a service, as a subscription. We only pay for that. We like it. We continue using it. The other is there are certain services we use as a redundancy. So, for example, Astra, you can do it. I don't know. I think I saw a press release, but one of the promises of Cassandra is you can run one data center in Google, one data center on Azure, and one data center on AWS. We have a Cassandra cluster that runs on 3 clouds. Okay. The other thing that we do on DigitalOcean, AWS, and Azure is we replicate our backup of our MySQL database, even though DigitalOcean does a pretty good job of managing backups and all that, as a ultimate redundancy.
Yep.
That if somebody were to completely screw us over, right, we have backups of everything on these other clouds that we can quickly come up. So those are the 2 reasons: redundancy and specialization. We like these different clouds for that reason.
Yeah, this approach known as multi-cloud, and actually many companies are using that.
Yeah, absolutely, and that's the way to go. You don't want to close yourself off with just one provider. You want to be kind of adept at a few of these tools that are out there.
Yep.
Yeah. So for each component, right, you have a different route. And each of these things you have to ask, do we want to, for example, do we want to move all of our software from Tomcat, web applications to, serverless Java on Azure Functions, or serverless Java on Amazon, or JavaScript? You may not want to do that yet. But the question really is, how is the DevOps going to change from how it is now to what is going to happen next? The DevOps is the most important function of the whole platform engineering process, because, like we've talked about it several times now, you don't manage the hardware. You don't even manage the operating system, right? You're managing the design of your system and how that design is translated into other people's platforms. And that is a combination of infrastructure as code, which you don't even need in many times. It's configuration information, and it's how to run the software for your company or your platform on that particular platform. So DevOps is the literal backbone, the foundation of how everything works. And you need to have a pathway for each system. How are we going to take this current process and make it work in the next system? Data operations is, I would say, as important or the next most important thing to think about. Just because you have your application running on the cloud doesn't mean that all of your processes that were running on-premise or on VMs or on whatever are going to be magically ported over for you. They may not work. So you have to think about, how are we going to move it forward? We like using Airflow. You can have an Airflow process to run your stuff as it is now, and you can make another process for how it's going to run in the future, and you can try it out. You can test it out. Services layers are very subjective. We're just talking about how you don't have to use microservices for everything. You don't have to use event-driven stuff. You don't have to use API gateways. But the question is going to come down, if you're using it now, do you want to continue using it in the future? Or if you're not using it now, would you want to use it? The DevOps for microservices or the DevOps for event-driven are complicated. And maybe you want to go straight into serverless functions, because it'll take some of the complexity away for you, right? And then finally, applications. Where is it going to be hosted? Is it going to be an iOS application? So is Apple going to be distributing this application? Or is it going to be a web app that people are going to access through their browser? So we want to make it fast, okay? So we have to use a content delivery network. Great, which one are we going to use? We actually use Netlify and Vercel. There's a billion out there. All of the major clouds have their own versions of these, by the way. Great, go use them. I just like using Vercel and Netlify, and they do a pretty good job. So we continue using them. If they become super expensive, we may consider moving to a more commoditized service like, CloudFront or Front Door. But for now, they're fine. They're pretty good. So this transformation, I would say, if you begin with your DevOps as your phase one, you will then know how your current software is going to run on your next software. And so when you start to make changes, how quickly it goes and runs on your platform in your staging, test, whatever QA environment, that continuous integration, continuous delivery. If you have that in place, your transformation is going to be much easier.
And if you don't have it, you better not start.
Yes, exactly. I like that. If you don't have DevOps practices in place, if you don't have continuous integration, don't start, because whatever you have is going to be magnified.
Yep. Or better to say first, start with phase one.
Yes. Start with phase.
Yep. Don't skip it.
You got to do DevOps transformation at the beginning, because everything else will be much harder. This is a picture that is from a site, daytree.io, and I think I found it on an Amazon article. But basically, GitOps, meaning how you manage your operations using Git branches and tags and automations around it, is the new normal, meaning everything, coding, testing, deployment is all done inside Git. It's saved inside Git. The configuration of that process is saved inside Git. And then the robots take over, right? They take over and do the work for you. As long as you save it in Git in the proper way, and GitOps is a very big subject, the robots that you create, or some that are created by other people, they take care of everything for you. And this is not just the gold, it's the new normal. If you're not doing GitOps, you're behind. Data operations is the next step, which is you've got your software, it's getting deployed properly. What do we do with our data operations? When you go to the cloud, and I kind of hinted at it earlier, if you're using a serverless database like Astra, you're paying for transactions for the reads and writes. So you may have operations that are being done by users or systems or IoT, and a lot of data is coming in, right? Now, if you need to do analytics on it, you may need to gather all of that data, do some analytics on it. With Astra, you're going to have to use something like Spark or Dataflow or whatever. You're going to gather all of that data. You're going to have to pull all that data from Astra, and you're going to have to analyze it and then push it back into Astra. So thinking about your data operations, what are we going to do? How are we doing it now? What are we going to do? That's phase two. And when you can figure out your DevOps and data ops, the rest of this stuff is much easier, because what you've really done is you've empowered the developers to actually, in parallel, start to migrate over in whatever way you want to go. So if you're going to figure out that, hey, we're going to use Kubernetes, or we're going to use, let's say, Netlify, or we're going to use, Vercel, you make that decision early on how you're going to do the DevOps for the front end or the back end or whatever. Then people that are creating the transformations from your current to your next, their job is much easier, right? Their job is just a matter of taking the code and following the new way that you've defined. And so these two things, the services and API and the application transformation, is much, much easier because you've done the legwork much earlier. What is phase 5? I don't know what phase 5 is. I don't know. It could be that, by the way, I think I know what it is. It's basically a combination of low code, no code, meaning clicks not code, plus GitOps. There's so much you can do with applications with no code, low. You can even do data engineering with low code, no code platforms out there. Well, if your company is starting to use these applications, how does that translate to your custom applications? How do we talk to that together? So I think I do know what phase 5 is, but you're always going to have custom code. You're always going to have your own data, and you're always going to have your own applications if you're a company that exists and continues to exist and continues to grow. So you need to have a strategy for your DevOps in order for you to support everything else. DevOps is basically Git to software, right? You can use it to deploy infrastructure. You can use it to deploy platforms. You can use it to deploy software. And that's how you could be doing things on the cloud right now. But eventually, if you're going to go to serverless, you don't even have to manage the infrastructure, right? You just need to manage your data model. You need to manage what your API is going to do. You need to manage what your front end is going to do. And Git will take care of basically deploying it. Not Git, but GitOps, whatever you end up using is going to deploy it for you. And somebody else is going to manage the scale, right? So this is eventually what you want to get to, but you got to get something in place now so that you can transition into this automated way of doing things in the future. And these are kind of like two examples of, for example, using Jenkins to do GitOps with Kubernetes versus using Azure DevOps, right? Everybody has the tools. GitLab has the tools. GitHub has the tools. Azure has it. Amazon has it. You don't even have to run these tools by yourself. You can just pay a company to do it for you, right? Jenkins X is the cloud version of Jenkins. Data operations. What do we use for data operations? Well, luckily, Spotify has put out their Airflow. Airflow is very, very popular now. You can also use Jenkins for data operations. Nothing against it. You just can't do as many complicated pipelines. Data operations is different from streams, by the way. We're not talking about event-driven technology right here. We're just talking about data processes, pipelines. I tell newcomers on our company, or newbies, right? I'm like, hey, all of IT is the same thing. Get shit into a database, get shit out of a database.
Yep.
Right? That's all we do. So if you have an app that is putting stuff into the database and you have an interface that people pull out of it, eventually somebody's going to ask for reports. Okay? Eventually people are going to ask you to do calculations. Well, how do you manage the continuous processing of those operations? That's what data ops is. So if you can get to data processes now, early, the future transformations are going to be much, much easier. And then finally, get to serverless APIs and apps. We kind of talked about it earlier. But these days, you have millions of options to host your custom API and your custom front ends. You don't have to do that. So, Netlify can store your Netlify can actually do some serverless functions as well. But I like Netlify for just the HTML, CSS, the raw static files. Vercel does Node applications and Next.js applications really well. We use Next for a lot of stuff. That's why we use Vercel. Vercel are the people that made Next. And ultimately, if you're using Astra, you may have some layer around Astra that you want to deploy that maybe takes two different tables and does a join and gives you that information, or it takes a transaction and saves data into three different tables. Whatever you're doing with Astra, you're going to have some middleware, right? And so that middleware has to sit somewhere. You don't have to, bring up a VM. I would say use Heroku. That's everybody knows how to use Heroku. Use Vercel. If you want to go a little bit more complicated, more powerful, make containers, make services on Docker, and deploy them using AWS Fargate. It'll infinitely scale for you. So lots of options to deploy your applications. And so that kind of brings me to the close of today's session, okay? Which is you have a lot of things to think about when you're planning your migration. It's not just your data. You have to think about your DevOps. You have to think about your software deployment. Because having the right fundamentals in place is really going to make your job a lot easier. Next time when we meet, next week, we're going to dig deeper into the data operations because, well, this is Data Stacks and we're talking about Astra. So we're going to talk about how do we migrate data to Astra? How do we migrate data from relational to Postgres? For let's say a relational database like Postgres to Cassandra in Astra. And what are the tools that we need to have in place so that as we're developing our applications, we can have our old version of the software running as well as the new version so that we can cut it over properly, right? You guys know that. You don't want to, it's like one of my favorite sayings from my dad is, don't quit your day job unless you get another job or unless your business takes off. I would say don't quit your old application until your new one is up and running and performant, right? So you have to maintain both. You have to maintain both. How are we going to do that? We'll talk about that next time. We have a bunch of resources that you can find on Cassandra.link. But that's pretty much it, guys. I don't want to keep you guys too long. I know folks are signing in from India and Europe, and it's late. But if you have any questions, just put them in the chat. And that's about it for tonight from me.
All right. I have 2 more points. So, first of all, thank you so much for joining. I've seen there is dozens of people stayed with us till the very end. And I want to say you are the best of the best because you want to be better developers, better engineers, better administrators, architects, and so on. And that's what makes us better in our job, learning, doing, improving, and so on and so forth. So thank you very much for joining. Second, I see there are people writing questions, and that's amazing. So keep writing, we will answer them. We have time. Before that, I want to proceed with the next things. And next thing is Cassandra is great, but again, as said, there are big problems. There are not enough qualified people to handle Cassandra, and because of that, many companies afraid to use that because they know what they cannot hire good enough engineers. But you know what? There are some people who are ready to be those engineers, like you. Because you attended this workshop, DataStax sponsors your certification and education in this field. So if you go to the academy.datastax.com, https academy.datastax.com, you can pass the courses, preparational courses for the exam, and with a voucher you will get to for attending this session. You can get both the training and certification exam absolutely for free. If you pass the exam, it's a real exam, so like it has to be strict. You will become a certified Apache Cassandra developer or engineer or administrator, and those guys are in high demand over the world, so it can make your professional life much more interesting. And second point, I already said what Astra has a very nice free tier. But if you are already big enough and you are above this free tier, which is, well, first of all, big success, so my congratulations. If you already certified for Cassandra, you can get a voucher to get this thing, you can get a voucher for Astra for $300 to spend on your Astra project, so Astra DB and Astra Streaming. And give me a moment to get a link, so I will send the link for you, so you will be able to claim your bonuses. Now, meanwhile, while I will be looking for the proper link, I can transfer some of the questions to you.
Sure.
So give me a moment. First, Raul. Well, that's Raul Bhojak. I don't know, sorry, how to pronounce the last name. Asks, Amazon Aurora is how different from Astra? Is getting from cloud, yeah, and moving, yeah. So Aurora to Astra, how would you compare that?
That's a really good question, and I have a good story about how they're different. So Aurora is, they claim to be a masterless MySQL, but they're not a distributed database. Each node in an Aurora cluster has the full copy of the database, And so when you write to one, it technically replicates the data to the others, and vice versa. So if you have data as it grows, even though Aurora is managing the replication into different nodes, your database server still has to vertically scale. Okay, so I'm not going to tell you which project, which client this was, but they had a service that stored user profiles, and they moved it from Cassandra to Aurora. And eventually, because of the demands of the application, they needed to have 20 Aurora servers to manage the reads and writes, to be able to do that many reads and writes. Okay, the same load only needed 3 servers of Cassandra, because Aurora is also locking, right? It's a transactional database. It's doing the locks every time you do an update, and it was locking the databases, and it was and I don't think they were using the right engine for MySQL, but basically you have row level locking, you have table level locking. That's why they needed 20 servers, because they had locking and they had these tables that were related. And so ultimately, that's one major difference. Is Aurora is not truly a distributed database. It's still a monolithic database. It just does replications for you. Cassandra is a distributed database. It takes your data and it partitions it in an intelligent manner around a cluster. So if you have 100 servers, right? Let's say you get that big, the client that is looking for the data does not need to go to a central load balancer to get that data. It knows where the data is because of the partitioner. So pure Cassandra does that for you. Now, when you compare Astra to Aurora, you're taking what Cassandra has to offer, and then you're adding this layer of not having to manage the underlying cluster. Astra can do way more transactions with less hardware and way less cost, because I know how expensive Aurora can get as you grow, especially because you have to replicate the data onto every server. So, sorry.
No. Why sorry? I'm completely agree. Yep. I want to mention what, in general, well, my heart belongs to Cassandra, for sure. I have, but there is no silver bullet. Yeah. So, Aurora can work in MySQL mode and PostgreSQL mode, and it's actually a great database, actually all of them. So I don't know what they have under the hood, mostly probably Postgre, and they support both of the APIs. Well, they both based on standard query language. And it's all managed because it's AWS Aurora, and Aurora is great database. I know there are success stories like Samsung, I believe, was quite happy with some of their migrations to Aurora, for example. Not complete migration, but only some parts. And it all in the end depends on your requirements. Like the question is, if we ask it like the way, what is better, Aurora or Cassandra? It will be like a question, what is a better, wrench or a hammer? Wrench is good when you use it in the right way. Hammer is good when you use it in the right way. If you will try to use hammer as a wrench, it won't work very well. And the same is, they both are good. They are for different scenarios. With Cassandra, you don't have a vendor lock-in because Cassandra is Apache Software Foundation, non-commercial, non-profit, open source foundation supported, first of all. Aurora belongs strictly to AWS. And there are so many differences also what was mentioned by Raul. Now, okay, I would like to take this one. How MongoDB is different from Cassandra. Yeah, I do think we need to run a dedicated workshop on that, because people ask that all the time. Mongo is one of the most famous databases in the NoSQL world, and for a reason. It's a great database. I used it for many years. First principle difference. There are many differences again, and a question which is better will be the wrong question. You know my position on that. Hammer and wrench, both are great if you use them in the right moment. So, first big difference, Cassandra is schema strict, so you create tables, you define design of your tables. Mongo is kind of schema-less because you can just throw any kind of documents and it will store it. Technically, schema exists, but it's hidden from the developer. It still consumes disk space and so on. It exists, but it's hidden from a developer. Well, when you scale Mongo, you can scale quite a lot for read operations, and Mongo for read operations scales quite well, as Cassandra does it too. But if you try to scale Mongo for write operations, you will run into very big problems very soon, because Mongo is not scales very well for write operations. It's not decentralized, and there are primary replicas, secondary replicas, or read replicas, and primary replicas are much harder to scale, and they are the only one you can write to. You cannot write to a read replica. It will drop your connection or will drop your request. And Cassandra is a truly decentralized database, so it scales as well for writes as for reads. From the scaling point of view, Cassandra is definitely a really stronger solution. So I would say, thinking of that first, thinking of which you should pick, you have to understand what's the pressure you're going to have on your database. Are you going to have global active data centers in Europe, United States, and Asia simultaneously? Because on global multi-data center deployments, Cassandra is better. Do you need to be able to use document API? Do you need to have this flexible schema or schema-less? So you could use Mongo if you require it to have flexible, or maybe you can go Cassandra plus Stargate to use document API, which is flexible schema with all the benefits of Cassandra. So those are the main differences. There are actually more, but we have limited time. Next question goes to you, I believe. Okay, that is a great question. Orlando Rivera Jr. asks, I would like to learn more about becoming an architect.
Great. It's a good question. So it's a statement, but I praise that, because when I first started in technology, I wanted to be an administrator, because I thought that administration was really cool, to be able to build things and then they just kind of ran. What I realized after being an administrator is that you can do cooler things by being a developer. And as I became a developer and an engineer, what I realized is that architecture is actually a combination of knowing administration and engineering, and then understanding how, not necessarily, but a lot of times understanding the business problem and how engineering and operations / administration are going to help solve that business problem. So now there are different types of architects. There's building architects, there's technical architects. In technology, you can have a data architect, you can have a network architect, you can have a systems architect, you can have a platform architect. Architecture is about being a lead technical person, right? The word architect, archon, I'm actually in Greece, right? Archon means like chief, right? And tech is about building. So an architect is a chief builder, right? Master builder. And to be a good architect, you have to be not only good technically with administration, operation, engineering, but you also have to be a good communicator. You have to be able to basically tell a story, because you're telling a story to the business stakeholders about why you should do a certain thing a certain way and why you need to spend XYZ money to buy this software or that software, right? And you need to be able to communicate with other people that you work with that are engineers that you're leading, because you're the leader. You have to communicate to them what needs to be created. So good architects are good storytellers that are able to take a very complex problem, draw a picture. Well, you have to be pretty good at drawing pictures, but like not like an artist, but just being able to draft an idea, right? um, but there's a really good book I found a while ago. It's called Enterprise Architecture as Business Strategy. It's a Harvard Business Review book. Highly recommend you read it. It talks about businesses and how they took architecture, technical architecture, to transform their businesses. And it goes through the four phases of every big business transformation, which is silos, right? Every business starts out with silos of information. They talk about standardization of the platform. Then they talk about creating a data core, and then they talk about business modularity. And so that book was the first time I saw how technology transforms companies to be more effective. And I think at that point, I really wanted to be an architect because I was able to understand what I was doing was actually helping businesses, which were helping customers, which were helping, everybody live life, basically, right? So really good book, Enterprise Architecture as Business Strategy. Highly recommend it.
That's interesting. And from my side, I would add one thing. For me, to be architect is to be always a little bit one step ahead of others in the knowledge point of things. When we talk about which particular 1, 2, 3. Okay, looks like we are back. My point is when you then your team discuss which particular solution you need to use for this particular service. Are you going to use Mongo or Aurora or Cassandra or Astra or looks like we are live. Hey guys, if you can hear us and see us, please set the thumbs up in the YouTube chat. Because at this moment, I don't understand if you can see us. But looks like we are live. Looks like we are live. Okay. So, yeah, okay, good. We are live. So, what I mean is, in general, I don't mean to learn any particular topic. Although there are a lot of particular topics you have to learn. But what I mean is you have to make the habit of learning and always knowing, you never know which next technology will become a new Docker. I mean, not from the containerization point of view, but that something will really change the world. What will be the next cloud you are going to use and so on. So it has to be a habit of learning. Make a habit of reading books related to your fields. You have to work with a lot of the databases. Read Database Internals by Alex Petrov. You are going to work a lot with different highly loaded platforms. The book, what was it? One with a pig on the face. I just forgot the name. That's not about the particular name. That's about the habit to learn. That's what brought me to a place I am, and that's what helped me to always be a better engineer than I was yesterday.
Yeah, absolutely. I think what you're describing is, there's what you do, right? There's your performance, and then there's how you get better, which is your skill.
Yeah.
And I would add one more, which is your personal development, which is when you get better at what you do, you can do more. Well, are you able to then handle that stress, right? Because architects end up having more responsibility, right? So you have to grow as a person, you have to grow professionally to be able to take the responsibility, because you end up being an architect of a platform that is serving thousands of users, right? It's responsible for the livelihoods of people that are working. Like, you have to be able to know the things and be able to manage yourself, basically. I think it's a leadership quality, I think. But skill development is a continuous process. Uh, Everybody that's here watching the webinar, right? I would say I spend maybe 3 to 4 hours a week at least reading new things,
Yes.
watching new videos, at least. But it ends up being more, because on a given day you run across a problem and you have to research it and you have to learn something new, right? So yeah, it's a job. Learning is a job.
Just a second, I'm answering a question. Serious. Yes, I found it. There was a question about Apache Pulsar or Astra Streaming solution content, and where is a short course? Boom. Good. So yes, that's it, and I believe we answered the question, or at least we did our best trying.
Yes.
And last one, I believe. How do you recommend using Astra for multi-tenant application? Can we have something better than application level isolation? From my point of view, when you want to organize isolation on a database layer, which definitely makes sense, you can use multiple key spaces, or for some cases you can use different databases, which will still be the parts of the same organization, yours. I'm only not sure on which scale do you mean multi-tenant organizations, because I don't remember what are the recommended amount of key spaces and what are the recommended amount of databases we have for Astra. But Astra in general should be completely compatible for multi-tenancy. So that's completely fine. Multi-tenancy, when you have a lot of data of different clients, that's no problem for Cassandra, of course.
Yeah, what I would add is that it depends on the nature of your software and its purpose. So if you're making software that has an economy of scale of having multiple users and businesses or whatever you're making, multiple tenants on your system so that you can do some aggregate data operations, then your multi-tenant design is going to be different. You're going to be using the same key spaces, the same tables, but with different segmentation in your actual design, right? Customer ID would be one of the fields. Versus if you don't need to have that, and you know that your customers are going to scale, and your application is built in such where a customer can have a key space and that's it, then I mean that is probably the best way, right? Because you're not managing the complexity of the cluster. If you can say, here's a key space and everything is going to work for the customer, and you can put the DevOps around it, even if a database at Astra, I don't know what the limit is, but the point is that, like, you can just make another database, right? It's abstracted. You don't have to worry about it.
Mm-hmm.
So I would say with Astra, you could go either way. You'd be fine.
Yep. Raul, could you please repeat the book name? I will copy paste it to the chat so people will.
Sure.
It was Enterprise
Architecture as Business Strategy.
Strategy. Okay, looks good. Then Raul asks. A good session, when possible, some more session with Anand architects. Well, I'm not from Anand Corporation, I'm pro DataStax, but I believe we make a good team. Now, a next session, because this one was a part of 3 episodes, Next session comes 1 week later, exactly the same time. 2 words maybe, Raul, what are we going to do there?
Sure. So we talked about a lot of things today about the general strategy. What we're going to talk about next week is data operations. And it's what type of data operations we need to prepare for in order to do a proper migration while running an old version and a new version of the same software, and without having any downtime, right? That's production systems can't go down. So some technical kind of abstract knowledge and some very specific tools and technologies that can help you along the way.
Yep. Okay, and our time is over at this moment. I want to say many thanks to Raul Singh and many thanks to our attendees.
Thank you, Alex, for hosting. I appreciate it. And yeah, thank you all for showing up. Glad you guys are here.
Yep. See you again next week. And don't forget, like and subscribe. Our YouTube channel, DataStax Developers, has more workshops to offer. Next one we are going to do tomorrow, so you can be our guests. Thank you and see you again.
Awesome.
A little bit music for you in the end to enjoy the end of this one.
I found someone new now. I have more room, no more formats to change.